That Bell Labs, bunch of smart people. I call it 1,200 PhD level people in Murray Hill in basically one giant building. And so that's a lot of people rubbing up against each other, and they're all doing technical kinds of things. And the environment did not tell people what to do. It was go do your thing, and once a year, one side of one piece of paper, tell us what you did, and that will determine how much money you get next year. But it was a very long cycle. The one extra thing is that it was a problem-rich environment. And so there were things that you could work on, and there was this, I think, very gentle gravitational drift towards doing something that somebody else might care about. Now, lots of people, who cares what other people think? I'm going to do my stuff. But I think most people got some reward, psychic reward from, I do something, I give it to you, and you say, that was great. And then you say, and you tell me all the things that aren't yet great. But that kind of thing was very common at the labs because AT&T at that time basically supplied telephone service to most of the United States, 1 million people, all kinds of interesting problems in and around communications. And so no matter what you were interested in, there'd be some part of AT&T that could probably make use of that. So that was part of it. But then there was the external world as well. The research community, Bell Labs was just part of the academic research community. So they were both outlets, and the labs was perfectly happy to have people do either. And so all of that, I think, worked out really very well. And it helped to have stable funding, because basically at that point, if you made a long-distance phone call in the United States, remember the concept of long distance, right? If you made one of those calls, a tiny slice of the revenue of that financed Bell Labs with the charter of make the service better. And we won't worry about the details of how you do that. So at the time, there was a lot of interest in programming languages. This all came out of the Multics experience, right? Where people at Bell Labs, and of course the folks at MIT, had realized that writing things in a high-level language made sense. And then the question is, what's the high-level language? And they started with PL1, which in the abstract sounded like a good idea, and in reality was a horrible idea because it was a horrible language. And so Martin Richards from Cambridge, University of Cambridge, had this language called BCPL, and he had spent, if I understand it correctly, a sabbatical year at MIT, planted the language in some sense. And it was much simpler, much cleaner, much better suited to system programming kinds of things than any version of PL1 would have been. And so the people at Bell Labs, Ken Thompson, Dennis Ritchie, and so on, had gotten some experience with high-level languages as suitable for writing lots of different things. BCPL wasn't a suitable thing for modern machines because it was typeless. And newer machines clearly were coming on stream that would have types like bytes and integers and maybe bigger things. And so at some point, Ken did a lot of experimenting. Ken Thompson did a lot of experimenting with simpler versions even of BCPL, a particular one called B, which was an interpretive language, no compiler. And that was, again, expressive enough that people started to like it. And that's sort of where I started in on this. I mean, I had written bits of PL1. It was awful. I'd written Fortran, better. But the B was sort of nicer to use, but it was still typeless and an interpreter as well, so it wouldn't be terribly efficient. But with the PDP-11 in the offing, and I don't remember the exact timing here, it was clear that a version of something that felt sort of like B, but which had some mechanism to include types so that you could talk about characters or integers, was going to be the way to go. And that's where Dennis picked up and started developing the C language and the compiler to go with it and so on. Portability was very much on people's minds at that time because although the core Unix work was done on the PDP-11, there were other machines at the time that were, in the same equivalence class. Interdata had a couple of 732, 832 numbers like that. And I think there were probably HP machines as well, and et cetera. And the other thing that was in some ways harder was that there was the big mainframe kind of computers that were used by the local computer center. And these were fundamentally stripped down versions of the Multics machines. They were GE 635 kind of things. And so those were big, clunky, word-oriented machines. They were, in effect, IBM 7094s cleaned up a bit. And getting something that would compile sensibly for those machines that really didn't have characters in a language which had become what it was, so it could manipulate characters. I think there was a bit of a strain there. But that portability, how do you get the same language to work on different computers? And Dennis's original compiler really was targeted at the PDP-11. And Steve Johnson came along with the portable C compiler, which basically separated the front end. Okay, let's recognize the language, let's build some intermediate structure, and then let's generate code for different kinds of machines. I had written a tutorial on B because I thought it was interesting. Maybe I can tell other people how to use it. And so when C started to be used, and I became somewhat better at using it, then I basically repurposed the B tutorial, brought it forward and made the C tutorial out of it. And so I used C for essentially all the software that I was writing at that time. And, kind of liked it. It was good. It was a nice match for the way people think about computing, I think, but also a very nice match for the actual hardware of the time. You could imagine what the compiler was doing. All of it was clear, so efficient and expressive and, nicely matched to everything around it. And then somewhere in probably 1977, early-ish, I coerced Dennis into writing a book about it. First edition came out in 78, and at that point the language was pretty reasonable. The book, I think, it was right on the cusp of whether structures were fully part of the language or not. A bit of overhang there, and I don't remember, but I think probably they were not quite, but awful close. And since Dennis was doing both compiler and book, it was at least a consistent viewpoint. The question is, can you pick up a structure as a unit and pass it around, or do you have to do something special? So I think, but that's a milestone. And then the next one is probably the 1988 book and the development of the ANSI C standard, the first standard, which is essentially, again, about the same time. And so I think those are the ways I measured. And at that point, call it 1988, give or take, just before you encountered it, C was probably just fine for anything you might reasonably want to do. And this is probably heresy or something, but I don't think that the changes in evolution since then have brought enough in some sense.